Welcome to Mechanical Drawing and Design N6. Today's presentation is going to be on spur gears and gear drives. Let's begin. First, we will look at some of the gear terminologies. Very important for you to be familiar with what a gear looks like and what is what on the gear. Okay, and so if this is our gear wheel, of course you can see that you have teeth all around the gear wheel. Okay, these are the teeth. And another component that is important for you to see is the hub. Okay, the hub is this block in the middle or in the center of the gear wheel. You can see there is a block in the center here. This block is what is referred to as the hub. And so if you measure its diameter, which will be the distance from here all the way to here, that is the hub diameter. And the hub is sometimes also referred to as the boss. So if somebody says the boss or the hub, it's one and the same thing. So inside of the hub, you will see that there is a cut that is made, okay, a circular cut. Okay, so what you see here is actually an opening, okay, it's a hole. It's a circular cut that is made for the shaft, okay? So if you measure the diameter of this circular cut here, so the distance from here to here, that will be the shaft diameter. And also you have this somewhat rectangular cut on top of this circular cut, and that is the key. Okay, you can see that. Okay, so that is the key, that cut there. And why is a key important? And it's because if you have a shaft, okay, that is connected to a gear wheel, you do not want to have slippage, because usually the shaft that is connected to the gear wheel will come maybe from the motor. And so it is supposed to transmit RPM from the motor to the gear wheel, okay? And so if you do not have a key, the shaft will somewhat slip inside of the hub. So what I mean by that, when the shaft maybe rotates by 90 degrees, the hub maybe will rotate by 89 degrees because there will be some degree of slippage. But if you provide an opening for the key like that, this will then make it possible for the shaft to be held nicely in place and to prevent it from slipping when it is rotating, okay, with regards to the gear wheel. And so with the key like that, then if the shaft rotates by 90 degrees, the gear wheel will also rotate 90 degrees because the key will prevent the shaft from actually slipping. Okay, there won't be any slippage. And it's the same thing also on the driven gear, because you have a driving gear that is the one that is connected to the shaft from the motor, but you also have a driven gear, and that is the one that has a shaft connected to it as an output. But even on a driven gear, you will also have a key because you want the RPM of the gear wheel to be perfectly transmitted to that shaft. Okay, that is very important. And so that's the purpose of the key. Okay, it's to prevent the shaft from slipping, okay, so that you do not have any form of slippage between the shaft and the gear wheel. Okay, so the RPM of the shaft will be exactly equal to the RPM of the gear wheel. Okay, very, very important. And another thing I want you to notice is that you have here a circle. Okay, you can see in these continued lines here, you have a circle. And what is this circle? This is the circle on which the teeth are actually meshing. Okay, so if you have two gears, if this gear is meshing with another gear, okay, what will happen? The teeth will make contact along the line of this circle, okay? That is where the teeth will be making contact, okay, along the line of this circle. So what I mean by that, if this gear was meshing with another gear, the teeth on the other gear will meet the teeth on this gear on points that are along this line. So they will meet here, 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 they will meet here. So you get the picture. And so this circle here, if we have to measure its diameter, then that will of course be the distance from here to there, for instance, and the diameter of this circle is called the PCD. okay, which stands for pitch circle diameter, because this circle is actually referred to as the pitch circle. Yeah, so its diameter is the pitch circle diameter, or just PCD. Okay, and there is another circle that is of importance when you're dealing with a gear, and that is the root circle. Okay, so that goes from the root of the teeth. Okay, the root of the teeth is the base of the teeth at the bottom here. Okay, so the circle there, okay, that connects all the roots of the teeth, okay, that circle there, that is what we will call, of course, the root circle. And then you also have another circle which connects the top face of the teeth, okay, so that circle there, okay, you can see that connecting the top faces of the teeth, okay. So that circle is referred to as the blank circle, okay? And sometimes we may also call it the outside circle, because this is the circle on the outside of the gear wheel, okay? So it is also referred to as the outside circle, but it is also referred to as the addendum circle, okay? So whether we say blank circle or outside circle or addendum circle, it's one and the same thing, at least as far as this module is concerned. And so what we're going to do is to have a close look at teeth, okay, on a gear, okay. So you can imagine we will zoom what you see here, okay, these two teeth, and if we do that, this is what we will get, okay. And so we will look now at the teeth on a gear and get familiar with some of the terminologies, okay. So the first thing I want you to notice is the line for the pitch circle, okay. The line for the pitch circle is this line that you see here, okay? That is the line for the pitch circle. That line that you see there, okay? That is the pitch circle line. Very, very important. Now, if you measure a distance from the pitch circle line, okay, to the top face of the tooth, that distance is called the addendum. Okay. If you measure the distance from the pitch circle line to the root of the tooth, or the base of the tooth, that distance is called the dedendum, okay? Very, very important. And so we also have something that is called the the hole depth, okay, which is pretty much if you want, you can look at it as the height of the tooth, okay, and that will just be the sum of the addendum plus, of course, the dedendum, okay? That is the whole depth of the tooth, okay? It's that depth here, addendum plus dedendum, okay? So it's the distance from the top face of the tooth to pretty much the base of the root of the tooth, okay? That distance there is what we refer to as the whole depth. It's equal to the addendum plus the dedendum. And also another thing I want to show you is something that is called the circular pitch. Now, the circular pitch is the length that you measure from one point on a tooth to the same point on the following tooth. Okay, so for instance, if we take this point here on this tooth, okay, if we take that point here, okay, then on the next following tooth, we take the similar point, which will then be this point here, okay? If we measure the distance from this point to that point, that is what we refer to as the circular pitch. So I repeat, it is the distance from one point on one tooth to the same point on the next following tooth, okay? So that is what we refer to as the circular pitch, okay? That distance there, that is the circular pitch. Now, the tooth thickness is equal to half the circular pitch. So once you have the circular pitch, you divide that by 2, that will give you the tooth thickness. Another thing that is very important for you to notice here is the face width, okay? You can see how it is measured, okay? So it's the distance in that direction that measures pretty much the width of each tooth, okay? So that distance there is what we call the face width from here to there, okay? That is the face width, that distance there, you can see it here. And you also have the clearance, okay? So now, what is the clearance? The clearance is pretty much the distance that you have when, imagine you have two gears that are meshing, okay? And of course, when they are meshing, the teeth from the other gear, when they mesh with teeth from this gear, okay, you will see, for instance, like in this case, in between these two teeth, you will have a tooth here in the middle here that is coming from the other gear. If this gear was meshing with another gear, you will have a tooth here that will fit in between these two teeth from this gear. And so that tooth will not go all the way to and meet even the base surface here in between these two teeth, okay? The top surface of the other tooth from the other gear will not come and make full contact with the base that is in between these two teeth, okay? But it will stop at some distance, and so you will have some clearance spacing somewhere here, okay? I hope you see what I am trying to explain to you. And so, so that distance then is what we refer to as the clearance, okay? So when two gears are meshing, okay, you will have their teeth, of course, in between each other, but then you will have some distance between the teeth that is coming from the other gear and the base surface on this gear, okay? So that distance, that is what we refer to as the clearance. I hope I am making sense. If we look at it, for instance, on this gear, you can see that between this tooth and that tooth, you will have a tooth here in between that is from the other gear. And the tooth that will be here maybe will stop, its top surface will stop maybe somewhere here, okay? And so that distance that you will have between the top surface from the teeth on the other gear and the base that you have here in between these two teeth on this gear, that distance between the top surface and the base, that is what you refer to as the clearance, okay? And so generally the clearance is equal to the dedendum minus the addendum. Very important, okay? And so these are the important things that I wanted to show you. Maybe just before I move on, I also want to show you the outside circle, and you can see in this picture it is referred to as the addendum circle, okay, because the addendum is measured from the pitch circle line to the top surface of the tooth, okay? And so if you measure, therefore, if you try and draw a circle that passes through the top surfaces of each tooth, okay, that circle there, you may also refer to it as the addendum circle. But as I said, for the purpose of this module, that is exactly the same as the blank circle or the outside circle. So I just want to show you a 3D picture of a gear. Okay, this is a Spur gear, and you have a 3D image of it, and I just wanted you to be able to appreciate what I was explaining to you, okay? For instance, you can see what the hub is, okay? So this block that protrudes in the middle here is the hub, and you can see the cut that is made in the hub, and you can also see the cut for the key, okay? Because all of this is to fit the shaft inside, so that you can very well match the RPM from the shaft to the RPM of the gear wheel, okay? You want to transmit that perfectly without slippage. And if you want to do that, you need to have a cut for the key, okay? That will prevent the shaft from slipping as it is spinning, okay? Very important. So you can easily transmit the RPM from the shaft to the gear wheel, or if this was a driven wheel, then you can easily transmit the RPM from the wheel to the driven shaft or the output shaft. Okay, very important. And you can also see the teeth, okay, all around this gear. Now let us look at some geometrical properties. Okay, we looked at the terminologies, but geometrically, how do you calculate them? So let us begin with the module. The module is basically equal to the PCD, which is the pitch circle diameter divided by the number of teeth. Okay, you will notice in this module we just use the letter T to refer to the number of teeth, but we also do have an equation for the torque which also uses the letter T. So it's up to you to know which T to use in what equation, okay? Because otherwise, if you start mixing them up and you think that in the equation for the module, this T is the torque, you're gonna be in trouble. So you need to be familiar with the equations and to know what T stands for, okay? Is it the torque or is it the number of teeth, okay? So in the equation for the module, the T here is the number of teeth, okay? So the module is equal to the PCD divided by the number of teeth. So the module is very, very important because it is also one of those geometrical properties that tells you whether two gears can mesh, okay? For two gears to mesh, they need to have the same module, okay? Very important. And by the way, I'm just assuming that you understand what I mean when I say mesh, okay? Basically, when we say that two gears are meshing, what we mean is that they are in contact with each other, okay? So that the motion of one affects the motion of the other, okay? They are meshing, their teeth are meshing, so they are in contact with each other and they turn like that smoothly and nicely. That is what meshing means, okay? We will see that very soon, okay? So the module M is equal to the PCD divided by the number of teeth. And for two gears to mesh, you want their modules to be equal, okay? Very important. And then you also have the circular pitch. I did show you how we measure the length for the circular pitch, but you can also get it using an equation, and the circular pitch is equal to pi multiplied by the module. You also have the tooth thickness, and as I was showing you earlier, the tooth thickness is just equal to the circular pitch divided by 2, okay? And then you also have the addendum. The addendum is just equal to the module. Then we have the dedendum, which is equal to 1.25 multiplied by the module. And then we have the clearance, as I said to you earlier. The clearance is equal to the dedendum minus the addendum, and that will just be equal to 0.25 multiplied by the module. So whether you do dedendum minus addendum or you do 0.25 times module, that will give you the clearance, okay? Very important. After the clearance, we have the hole depth, okay? This is just the depth of the tooth, and it is equal to the addendum plus the dedendum, okay? Or if you want, you can do 2.25 multiplied by the module. That will give you the whole depth of the tooth. And then you have the working depth. Now, the working depth is the depth of the tooth without taking into account the clearance, okay? So, in other words, this is equal to twice the addendum, or if you want, it is equal to twice the module, because the module is equal to the addendum, okay? I repeat, the working depth is the depth of the tooth excluding the clearance, okay? So that space for clearance, if you exclude it and then you measure the depth of the tooth, that is what is referred to as the working depth, and it is equal to twice the addendum or twice the module. Very important. After the working depth, we have the root diameter. You will remember as I showed you the root circle, okay? So if you want to measure the diameter of that circle, you will find that it is equal to the PCD minus twice the dedendum, okay? That is what will